Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at using pointers within your applications. Once upon a time in programming languages, the creation of areas to store information, which would become variables, was quite complicated. However, modern programming languages make this much easier for the user. Modern computers have a great deal of memory, and as a programmer, you don't need to worry about where exactly in memory your variables are held. Your programming language and the operating system does all of that work for you. What we're going to look at today are the use of pointers to variables. So first of all, we're going to create a user-defined type in which we can actually store information. We will create this user-defined type at the beginning of our application before the pb-main function. This user-defined type is going to hold some stars information. It will hold three elements of information: an x, y, and z coordinate. And in addition, we'll also store a mass. We're storing all of these as single variables. If we have a look at the single type variable, this is a single precision floating point variable. Therefore, it is quite suitable for storing information which has a value after the decimal point, unlike long variables which store whole numbers. The single type variable can hold values to the limit of 6 digits of precision. For what we're going to be doing today, this level of precision is enough. However, in your own applications, you may find the single type of variable is not precise enough for your calculations, in which case you may want to go for double precision floating point. This, as you would expect, takes up twice as much memory as your single precision, and will allow either 15 or 16 digits of precision versus the 6 digits of single precision. Should you require even more precision, you can go for the extended precision type. This will take you up to 18 digits of precision. But as I said, for today we're going to stick with single precision. Now that we have created a user-defined type called UDT stars, we can actually refer to this memory structure within the rest of our application. And in our pb-main function, we can declare a local variable as this user-defined type. In this case, we're calling our local variable uStar. So now that we have this little structure in place, can we populate it? A method of populating it is using the name of our variable, uStar, followed by a dot, followed by the element within that user-defined type that we wish to populate. In this case, we're putting in a random number. This would be a random number between the value of 1 and 1000, plus a value which is between 0 and 1. So in order to make our random numbers as random as possible, we're going to seed the random number generator by using the timer. This ensures every time we actually run the application, we will get a new seed. So we can populate each element of this user-defined type by specifying the name of the variable, in this case uStar, the element of the user-defined type, and giving it a value. And we have seeded our random number generator by using the timer. This ensures that each time we run the application, we will reseed the random number generator. If we did not use the randomize, we will get the same sequence of random numbers every time the application was run. So now that we have populated each element of our user-defined type, let's print it out to the log so we can see the values. Since each of the values of our user-defined type is a number, we're using the format command to turn this number back into a string so we can assemble a series of strings to print out to our log. If we try running the application now, we will see we have a value for each of the elements x, y, and z plus the mass. So we have created a user-defined type, we have populated it, and we have printed it out to our log. However, there are a few tricks that PowerBasic has to make life a little easier. Rather than specifying the full detail of each of the elements of the user-defined type, you can use the prefix command. If we comment these out for the moment, and we use the prefix command to do exactly the same piece of work. This change using the prefix command is functionally identical to the previous code. All this is doing is giving the PowerBasic compiler an instruction that at compile time it's to prefix each of these 4 lines of code with u star dot. It doesn't make your code run any differently or any faster. It merely gives you a way of tidying up the code and making it more obvious when we're setting multiple values of the same object, and does save a little bit of typing. If we run the code again, we'll see it runs exactly as it did before. So as this video is to be about pointers, how are we going to use a pointer to reference this user-defined type? Well, first of all, we're going to comment out all the code we've written already. And we will create our user-defined type as we did before using the local command. Next, we're going to prepare a pointer. We can do this very easily by declaring the name of our pointer, in this case single star, and it's declared as a user-defined type stars. And the very last word on the line of code is pointer. So this is a variable that's going to be used to point to this particular user-defined type structure. Next, we're going to populate the pointer with a value. We can do this using the var pointer command. So in this case, the variable we've prepared as our pointer is going to be equal to var pointer u star. This means the single star pointer is now pointing at the structure in memory we have created when we used the local u star as UDT stars command. This gives us a value we can now pass to other functions and subroutines. So we're going to create a function which will prepare our star values. So we can take the code out of this PB main function. And we're going to give one parameter to this new function, which is our pointer. So let's go and create this new function taking its single value parameter. So here is the skeleton of our new function, prepare star, taking its single parameter. Pointers are required to be passed by value. So we precede the name of the variable with the word by val, and it's declared as a user-defined type stars pointer. So let's now go ahead and populate the stars details, exactly as we did before, using our prefix command. As you will see, this code looks a little bit different. We're using the prefix as we did before to prefix the string that follows the word prefix on each of the following lines of code. So we can see the X, Y, Z and mass elements have all been populated exactly as we did before. However, the prefix has an @ sign in front of the variable name. This indicates that it's a pointer. So we're going to populate the user-defined type that was defined in the PB main function. We're doing this directly from this line of code, p star dot and followed by the element. So this will populate the value we had in our PB main function. So having populated this user-defined type, can we now print it out, again using another function? So we will create a new function whose job in life will be to print this user-defined type. And we are again giving it the single parameter, which is our pointer. And here is the skeleton of our new print star function. As before, since we're passing a pointer, we're passing it by value, exactly as we did previously. And we're going to take the same approach to printing it out to our log. We're using the format command, and within the brackets we have our number. And we're referencing our pointer by using the @ sign followed by the name of the variable, which was passed in the parameters list. Using this mechanism allows us to identify the area of memory in which our data is actually sitting, without having to know where this is in actual memory. So if we try running our application now, we will see there is our values popping out quite happily. We have the details of our single star, X, Y and Z coordinates, plus the mass. So functionally, our code is exactly the same, despite the fact we're now using pointers. but our code is quite clean in the fact that we have a prepare star function which prepares the value in our user-defined type, and we have a print star function which prints that user-defined type out to our log. So now that we've taken a single user-defined type and populated and printed it, can we now dimension an array of this user-defined type to have many stars rather than just one? Well, we can quite happily use the dim command to create an array. In this case, it's an array of this user-defined type, UDT stars. And as we've dimensioned it with the value 100, this means the array goes from element 0 to element 100. So we now want to populate this array with values. So we're going to create a local variable to allow us to use a for next loop. And we're going to prepare a pointer, again to this user-defined type, just as we did before. And we're now going to step through each star in our array using a for next loop. We can determine the upper bounding of our array using the ubound command, which will return the value 100 as we have 100 elements within our array. Now we can populate the pointer for the element of the array to point it at the specific element we're processing. And again, we're going to do this by using the var pointer command. So our p star pointer is pointing at the first element of the stars array. And then when the for next loop triggers on next, it will then point at the second element of the array, and so on. Having pointed at the element of the array we wish to process, we can now call the function we've previously written to prepare the star. Note that we don't have to change the function. We're passing it a pointer, just as we did before. The first time we called prepare star, we were populating a single user-defined type. Now we're populating a user-defined type that sits within an array. But as we're passing a pointer, we don't have to change the function at all. So if we run this now, it will run without error. But having populated this 100 element array, we now want to see has the data arrived. So rather than print out all 100 elements, let's print out just the first 3. So we will send a message to our log to say we're going to start printing our array data. And again, we can use a for next loop. And just as we did before, we're going to be using the var pointer to point at the element of the array we're going to be processing. And just as we did before, we're calling the function we created earlier called print star, which will print the details of this particular element out to our log. Again, as we're passing it a pointer, the function does not need to change. So effectively we have two functions that will operate either on an individual user-defined type or a user-defined type within an array, because we're using pointers to pass as the single parameter. So let's try running the application now to see if we get our 3 values coming out. What we'll see at the top is our value for the single user-defined type, and for our array we've got 3 values for the first 3 stars in our array. So we have successfully used 2 functions to operate in 2 different scenarios. One for a single user-defined type, and the second for a user-defined type which is held in a 100 element array. You can of course print these without using pointers. If we put a piece of code in our pb main function to print without pointers. And we're going to set the value of our long R to be the value 3, so we're looking for the third element of the particular array. And we can use the long format to print out the details of our array. So there is the element of our array, and there is the element inside the user-defined type we're printing out. If we run this code now, you'll see here is the third element of our array printed using the pointer. And as you can see below, printing without the pointers gives us exactly the same value. So this gives us clarification that we're pointing at the same part of the array. So in summary, what we've achieved today is we have demonstrated the use of pointers to user-defined types, both as a single user-defined type or as a user-defined type held within an array. This gives you the flexibility in that if you are passing the parameter, which is a pointer, it gives you more flexibility. You can use the same function for two separate purposes. Hopefully you'll find this approach useful in your applications, but that's it for today. Thank you for watching.